took a look at this next problem, but there's something a little different about this next problem. Let's talk about it. Sine 90. Now, who can tell me what's different about it? Jack? What? It's on a line. It's what we call a quadrantal angle. A quadrantal angle is an angle that when you draw it in standard position, it terminates on an axis. So 90 is an example. What would be some other examples of quadrantal angles? 180, 270, 360, negative 90, right? Pi over 2, pi, 3 pi over 2, negative pi. Anything on an axis is quadrantal. And this poses a problem. If you think about what your strategy has been, like those problems you did right before lunch, you drew the angle, dropped the perpendicular to form a triangle, right? We got an issue here because you can't drop a perpendicular and form a triangle. Now, some of you are going to try to draw a triangle like this, and that of course will whip me out because every triangle you draw is going to be a butterfly bow tie. So we can't draw a triangle. So what we do with the quadrantal angles is, instead of drawing a triangle, we draw our unit circle. This is called the unit circle. And what it means to be a unit circle is, your center is at the origin, of course, that's where everything begins, and the radius is 1 unit. The radius is 1. So I automatically know that the radius is 1, which means that this is the point 1, 0. This is the point 0, 1, negative 1, 0, and 0, negative 1. So I have just labeled an X and a Y for every quadrantal angle. Agreed? I automatically know my radius is 1. So I have an X value, a Y value, and an R value for every single quadrantal angle. Wait a minute. What sine? I know it's opposite of hypotenuse, but what's the other definition of sine? Y over R. Well, here's 90 degrees, right? Y is 1, and R is 1, so the sine of 90 is 1. How easy is that? So the next one says cosine pi. Well, pi is 180, right? Is that also quadrantal? Yeah, it is. What's that point? Well, that point's right here. Would everybody agree this is where pi is? Or 180, if you want to think about it that way. So we know that x is negative 1, y is 0, and r is 1. What's cosine? X over r. That's on your sheet. You don't already have it memorized. You got to get it. Cosine is x over r. So x over r will be negative 1 over 1. So cosine pi is negative 1. If you typed into your calculator cosine pi in radian mode or cosine 180 in degree mode, it will say negative 1. That's the cosine of pi. All right? Tangent 3 pi over 2. Can you tell me, without changing that into degrees, 2 is. Remember, this is pi, right? And this is 2 pi. So isn't 3 halves right here, right in the middle? So this is where I'm looking, and I want the tangent. So I remember that tangent, off my yellow sheet, what's tangent? Don't say opposite over adjacent, that won't work. I don't have a triangle. I need the other definition. What's the other definition? Y over x. So at that point, I know x is 0, y is -1, and r is 1. Did I turn this on, I hope? Yeah. So what is y over x? Oh, we got a problem, don't we? -1 over 0. So the tangent is undefined. There is no tangent of 270, or 3 pi over 2. If you typed it in on your calculator, it'll say error undefined or something. It'll tell you you can't do that. On the back of your yellow sheet, I have the curves drawn. Would you look at the tangent curve? Do you see how it has asymptotes in it? Those are the places that it's undefined. The tangent is going to be undefined because there are places where x is 0. Will the sine and cosine ever be undefined? No, because what's the denominator of the sine and cosine? R, the radius. Is that ever going to be 0? Is the radius ever going to be 0? No, the radius is always 1. So we're not going to have any issues with sine and cosine, but the other functions we're going to have problems with. Sometimes they're just going to be undefined. All right, let's try the next one. Secant -pi over 2. Secant -pi over 2. Oh shoot, I shouldn't erase my circle, but that's all right. I can draw it again. Secant -pi over 2. All right, so here's my unit circle. Where is -pi over 2? Where is that located? Negative y-axis, right? -90, right down here. That point is 0, -1. If I let the radius be 1. So x is 0, y is -1. Okay, secant. Reciprocal of cosine. Cosine is x over r. So this is going to be r over x. Oh, we got a problem again. R over x is going to be 1 over 0. So the secant of -pi over 2 is also undefined. Does that make sense to you? Now, there might be this nagging feeling in the back of your head, like this is for, wait a second, how can you just make it up so that and say I'm going to have a radius of 1? What if I used a different circle? What if my radius were a different number? Let's do this problem again. Cosine pi, I remember the answer came out to be -1. Let's see what happens if I do a different size circle. So let's suppose that the radius of my circle was 77. That's the year I graduated from high school. 77. Now, what would that make the coordinates of this point? We're doing cosine pi. Pi is over here. What would be the coordinates of that point then? -77, 0. So now, my values, x is -77, y is 0, and r is 77. Cosine is x over r. What's going to happen? I still get -1, don't I? The size of the circle doesn't matter. it can be whatever size you want. Why do we use the unit circle? Because there's no easier radius than 1. But if you want to do a different number, go ahead. Every time I do it, I'll use a radius of 1. Okay, well that was fun and interesting. All right, there's 2 more here, and then we'll do some really fun and interesting things. Cotangent 780. Cotangent 780. Tell me about 780. Way too big, right? In fact, I can go around twice and still have 60 degrees left over. So I'm going to draw my triangle just like this. My angle is 60 degrees. There is no point in drawing the extra revolutions. So I'll just find the smallest positive coterminal angle. And how do I find coterminal angles? I subtract 360. So I just subtracted 360 twice. And that gave me my smallest positive coterminal angle. So I drew it 60 degrees. Root 3, 1, 2, that's a 30, 60, 90 triangle. Should anything be marked negative? Nope, because I am in quadrant 1, so everything's positive, it's all good. What's the cotangent? X over y, or I got a triangle, I can use adjacent over opposite if you want to. It doesn't matter, you can use either one. This is X and this is Y. This is also adjacent and opposite. So 1 over root 3 or root 3 over 3. You can use either definition. So how did I get 60? The smallest positive coterminal angle. How did I do it? Subtracted 360, subtracted revolutions, right? Which is what we talked about right at the beginning. Cosine 0, let's find it. What's the cosine of 0? Oh, I'm not going to be able to make a triangle. Would you agree? That's a quadrantal angle. It's right here. So X is 1, Y is 0, and R is 1. If I let my radius be 1, this is the point 1 comma 0. Cosine is X over R. The cosine of 0 is 1. If you type that in on your calculator, you're going to get 1. We're going to do one more problem. You're like, oh, thank God. Oh, wait, no, we're not. I think we're out of time, aren't we? So we timed that about right. But we will definitely finish this up on Monday, so that homework will be due on Wednesday. What? What did you say?
I thought we were done like 1 for some reason.
I wish we were.
I know. It's more
I wish
math
we
though.
were. All right, let's clear off everything, and I'll come around. All right. I'm positive this ends at 12:40.